going to determine them with the second derivative test, which I have to explain. Anyone would like to pick a graph or not? Or I will. No one wants to pick a graph.
We'll do 4.
Yes, let's do 4. So we see here that the function opens upward till this point right here, where the concavity changes. And all of a sudden, it starts opening downward. So up, 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 not increasing. I don't mean that. It means opens up, it holds water, and then it doesn't. And then it does again. So, identify the points of inflection. Can anyone identify any point of inflection on this graph number 4? We want to identify the points of inflection on this graph, number 4. Anyone?
-1, 2.
Excellent. -1, 2. That's one point of inflection right here. Excellent.
1, 2.
And 1, 2 right here. Awesome. I'm going to write them down for you. So this is number 4 on page 290. So IP, we have 2 IPs, -1, 2, and 1, 2. Good. Now we want to also write where the function is opening upward and where the function is opening downward. Can anyone give us opening upward or downward, whichever you prefer? So the function is opening upward from -infinity to -1, union 1 to infinity. Can anyone give us the interval on which the function is opening downward?
-1 to 1.
-1 to 1. Awesome. So thank you very much. So the function is opening upward between -infinity and -1, union 1 to infinity. And it's opening downward between -1 and 1. Awesome. Great job. Now we want to choose a function and find everything. Max, min, and everything about the first derivative, everything about the second derivative, and no, we're not going to sketch the graph just yet. On the first example, I would like just to determine everything. Well, I mean, we can also put it in because now we have all the information. We can. Anyone would like to choose, or I will? I will choose 19. So 19 is g of x. They love g of x. X to the third minus 6x squared plus 9x and plus 1. So we want everything now from the first derivative, everything from the second derivative, and we can, yes, at this point I think we can graph. I have to start my table. And the table will have now the second derivative added in. So x g prime, g of x as we had it so far, but now we're adding at the very end the second derivative. X g prime, g of x, second derivative. We have to start with the domain. Can anyone give us the domain of this function? And I will put it in. Anyone? Domain of that function.
So it would be the negative infinity
Yes,
to infinity?
absolutely. It's a polynomial function. Everything goes. Great job. What is our next step? We normally have to put 0 in the table at all times, so unless the function is undefined there. So can anyone give us g of 0? So I can put it under 0 here.
1.
Yes. 0, 0, 0 plus 1. Awesome. Great job. Good. What will be my next step? I want everything. I want to study the first derivative. I want to study the second derivative and find all the information, fill out the table, and then graph. For the first derivative, what do I need to do first?
I would just put two numbers in between, so like -2 and +2. And
I
see
don't
how it
have
works.
g prime yet. I don't have it. I haven't determined it yet.
Okay, it needs to get g prime,
Yes, very good. So let's find g prime.
which would be 3x squared minus 12x plus 9.
That's it. Since we are here, let's also find the second derivative.
That would be 6x minus 12.
Perfect. So let's take it easy. We start with the first derivative. So the first derivative, g prime of x, of course I will factor out the 3, and I have x squared minus 4x plus 3. Yes, you can use the app in the calculator, but this is too easy. Can anyone give us the factored form?
X minus 1 and x minus 3.
Very good. So now we need to set it equal to 0 or undefined, because we have to determine the critical numbers. Okay, good. So can anyone give us, first of all, can anyone tell us if this can be undefined?
No.
No, it's a polynomial function. When g prime is 0, can anyone give us the two values right away? When we set g prime equal to 0?
-1, -3.
Careful.
1 and 3.
Why? Very good. Is that clear why it's 1 and 3?
Yeah, I see it now.
Perfect. Careful, we have to put them in the correct order, 1 and 3. I'm going to move 0 a little bit to the left because I don't like when the table becomes too crowded. So I'm going to erase these two from here. Because I moved 0 further to the left. Perfect. Now, what do I put in g prime, in that row for g prime, under 1 and under 3? Under 1 and under 3, right here.
0.
Of course, that's how I determine them. At this point, I have to plug in 1 and determine the value of g when x is 1 and the value of g when x is 3. I want to put this function in the graphing calculator. You know how I like to do it. I hope you do too. So get out of there, go to y equals, clear everything, and put in the function x cubed minus 6x squared plus 9x plus 1. And we go to second and table and quickly plug in 1 and 3. They're already there. So at 1 is 5. And at 3 is 1. Good. Awesome. That's how you should do it. Not plug in and repeat and repeat. That's not a good idea. Good. So let's recap. I determined G prime. I found critical numbers. I put them in the table. I put the zeros because it comes from zero. If they were coming from undefined, I would have said undefined, a bar. But they come from the source being zero, so G prime being zero, so I put 0. The next step is I need the sign here, the sign here, and the sign here. And I'm done. Then I will be done with the first derivative. So if I plug in -10 or 0, that's even easier. If I plug in 0, this is negative, this is negative. 3 times negative times negative. What is the sign here?
Positive.
Thank you so much. Careful now, we have to plug in 2. 2. 2 minus 1, positive. 2 minus 3, negative. Positive,
So it's negative.
so it's negative. Excellent. I'm going to plug in 10 to the right of 3. Anything to the right of 3. 10 minus 1 is 9. 10 minus 3 is 7. 9 times 7 times 3. I don't need the calculation. I only need the sign.
Positive.
Perfect. One thing we have to add to the table. Something here. And something here. What does that mean? Well, our best friend, as x approaches negative infinity from g of x, and limit as x approaches infinity from g of x. At x approaches negative infinity or infinity, which of these 4 terms is the most powerful, the one that leads? I'm talking about infinities or negative infinity. Which one is the most powerful? The one that will dictate. From these 4 terms, which one?
X a third.
Excellent. So don't even bother with the other ones. Plug in negative infinity and tell me what to write. And then plug in infinity and tell me what to write. Negative infinity to the 3rd power. What will that be? Negative what?
Negative infinity.
Excellent. And here, infinity to the 3rd power would be what?
Positive infinity.
That's it. Negative infinity, positive infinity. At this moment, we came to the moment of truth. That's the moment of truth. If these 2 rows do not work well together, I will say, oops, something is terribly wrong. I have to start from scratch. We hope it's not the case. From negative infinity to 1, what does the function do?
Increases.
Is that supported by the sign of the first derivative?
Yes.
Awesome. What does the function do from 1 to 5?
It increases.
Is that supported by the sign of the first derivative?
Yes.
Awesome. What does the function do from 5 to 1?
It decreases.
Is that supported by the sign of the first derivative?
Yes.
Perfect. Final question. What does the function do from 1 to infinity?
It increases.
Is that supported by the sign of the first derivative?
Yes.
Done. The first derivative is completely exhausted. We cannot learn anything else from it. We exhausted it to the bone. Now we move on to the second derivative, which we already calculated. In the same way we analyze the first derivative, we will be analyzing the second derivative. The second derivative was 6x minus 12. G prime equals second derivative equals 0, and the second derivative undefined. Is this possible for this function? Can this be undefined?
No.
No, it's a polynomial function. G double prime equals 0, 6x minus 12 equals 0, and we move 12, it becomes positive, we divide by 6, and we get x equals,
2.
that's it. Now, I have to put it in the correct space. I have to write under it for the second derivative 0. And now I have to study the sign of the second derivative. I have to plug in 2 because I need this point, 2 comma what? But I have it ready. That's why I put it in. It's right here. The function is there when x is 2, y is 3. That's it. I don't have to calculate anything. It's already there. Awesome. So now we are looking at this function. We plug in a number to the left of 2, any number. The easiest one will be 0. And I just need the sign. When you plug in 0, what will be the sign of this function? We don't care about the number. We only want the sign.
Negative.
That's it. When the second derivative is negative, the function opens downward. Good. On the other side, when I plug in 10 to the other side of 2, 10. When we plug in 10, what is the sign of this expression? We only need the sign.
Negative.
Careful. 60 minus 12.
Oh, positive.
Positive. Awesome. When the second derivative is positive, the function holds water. What type of point is 1 comma 5? I should have asked that before going to the second derivative. Sorry about that. What type of point is 1 comma 5? Relative max. What type of point is 3 comma 1? 3 comma 1.
Min.
Yes, relative min. Final question. What type of point is 2 comma 3? Has nothing to do with the first derivative. It only has something to do with the second derivative. So what type of point is 2 comma 3?
Min.
Careful. The second derivative only gives IP. The first derivative only gives max min. The second derivative only gives IP if it changes sign. So let me write this down before do I still have time to graph this function? No, I don't, but we'll do it next time. But I need to finish with the explanation about inflection points. So for the second derivative of a function, if the second derivative is negative, 0, positive, or negative, undefined, positive, that is an inflection point. Or vice versa, positive, 0, negative, positive, undefined, negative, this is also an inflection point. Now, if the second derivative is positive, the function holds water. If the second derivative is negative, the function does not hold water. Concave upward, to be correct, not hold water or not. Concave upward, concave downward. Second derivative positive, concave upward. Second derivative negative, concave downward. So on Monday, we're gonna continue from here and graph this function. We have all the information we need. We have concavity, we have increasing, decreasing, we have relative max, inflection point, relative min, and behavior at infinity. We have everything we need.